Hi, good day. In this video, we will continue with our design of two-story residential building with hip roofing system. I had already created a video tutorial similar to this, but that video was about the design of two-story residential building with roof deck. So it looks similar, but the procedure of the design is totally different, and this is more complex than that one. So sit back and relax. Actually, the main purpose of this channel is to help the engineering students and the new engineers who haven't yet tried using software in the design of building structure throughout their career. So nowadays, the use of software is very advantageous in the design and advantageous to the applicants who possess a lot of knowledge about software like Staad, ETABS, and others. There are a few ask me if I can provide them a spreadsheet, especially the loading type that I use in my sample design, and how did I get this. And you know guys, it is one of the important things to study first the National Building Code prior to designing. And the familiarization of National Structural Code of the Philippines is a good start. All the loading type and the specification about building design come from that code. So totally, the design data differs from one engineer to another depending on what type of structure he is designing. So if you are new to this channel, please consider subscribing so you won't miss any tutorial that I upload every week. If you are an engineering student studying mathematics, basic algebra to calculus, design, basic physics, and others, then this channel is ultimately best for you. And you will learn a lot from this channel, and I will be uploading thousands of videos similar to this. So let's get started. So this is now our structure, and we model this in our video series, in our previous video series. So if you haven't yet watched that video and you want to study the process of modeling, then you can find the video link in the description below. Now our basic load combinations come from NSFA section 203.3.1, and that would be used in the strength design and drift calculation of our model. Strength is the ability of the structural elements to resist the applied external force without breakage, while the drift is the relative displacement experienced by the vertical resisting element like columns. During earthquake event, you know guys, a structure vibrates due to earthquake force, and it is forced by that earthquake force to move back and forth like an inverted pendulum. So in here, if the displacement is not controlled, enormous damage to the structure will be expected, and eventually a total collapse of it is next to occur ahead if the drift is ignored in the design. So it is very essential to control this displacement to avoid damage of the non-structural elements anchored within the structure. So if any of this gets damaged during earthquake, then instead of stopping, a horrifying scenario will intensify. Imagine the structure. How risky will it be inside, dancing with uncontrollable movement? To control this displacement to a certain level, we have this equation from NSCV, and I already extracted this and put into my Excel file, so it would be easy for me to copy and paste and pretend it's been there for a long time and get nothing to worry about creating auto load combination. Here in my Excel file, this group of equations here is for my footing design, service check combination coming from that section. This group of equations controls the size of footing. When the time has come to check sliding and overturning capacity of the structure, equations used here in are those unfactored equations so as to intentionally reduce the weight. Our total floor load is 6.35 kN per square meter for bedrooms and living room, 6.7 kN per square meter for T and B, and the live load is 1.9 for all locations except balcony, where the balcony, the live load is 2.9 kN per square meter. Partition wall, we use drywall, and we use CHB at external walls. For all of these loads, you can go to any CFA table 204-1, 204-2, 205-1, 205-2, and 205-3. We have also loads coming from trusses. Later on, I will show you how to apply that roping load extracted from previous model. Let's go to reference load definition. Our first load type here is dead for dead load. Just name this reference load DL, then add, next live for live load, and just name this reference load LL, add, then close. Highlight reference load DL, then click add. Let's first add self-weight load, no other than the dead weight of the modeled members. Factor is +1. Then click add. Highlight the self-weight beside the colored red question mark. Then click assign to view. Then click assign. Meaning our self-weight is the weight of this entire structure that we see here. And it is highlighted automatically right after the application of self-weight load. Click reference load DL again. Click add, and this time we will add floor load. But before this, by the way, I remember when I saw this group here, we haven't yet created a group for our load application. When we apply floor load, there are two ways to do this. One is by the use of range. As you can see here, we need only to define the Y, X, and Z range. This is the distance of any floor under consideration to the reference point. Say for example this ground floor. Let's say we apply a load of 2.4 kN per square meter. So to do this, we need to know the distance. Highlight the reference load DL.
Click add, then click floor load. Type here +2.4. Now for Y range, the application starts right here, which is 2 meters from the reference point, and ends here, which is 2 meters.
So therefore, type minimum 2 meters and maximum 2 meters. For X range, the application of load starts here, which is 0 from the reference point, and ends here, which is 10 meters away from this point. And always remember, this is our reference point here.
So type minimum 0, maximum 10.
For G, the application starts here, which is 0, and ends here, which is 15 meters away from this reference point. So type minimum 0, maximum 15, then add. So this is the loading.
Now there are cases where floor loads application is quite time consuming
and is confusing to do if the floor system has many openings and discontinuities. So in that case, the use of group is the better option. So let us create group. By the way, let me erase the previous load application. To create a group, let us isolate first second floor since we want to apply the floor load at second floor. So let us isolate.
Go to Select, then click Attributes, then Group.
Now click Yes to create, or you can exit this and on our keyboard click Ctrl plus G. So if for a certain floor the quotient of longer side divided by the shorter side is less than 2, then the slab is a two-way slab. Otherwise, it's a one-way slab. So we will use that here. We'll create two groups of two-way slab and let us name it 2F underscore 2E underscore 1. Or any name as long as it is easy for you to locate the group in the structure. Otherwise, you'll confuse yourself the whole day. So it's 2F underscore 2E underscore 1 since it's a two-way slab located at second floor. And it is first group. So if it is on the ground floor, then we can say GF underscore 2E. Simply means two-way slab on ground floor and leave no space between words and letters in the name of that slab or that group. Select floor, then click OK. So this is now the group, but if you notice, it is unassigned. To give this group an assignment, select all the two-way slab like this except for T and B. After that, click Associate to selected geometry, then click Associate. And you see it is now assigned. To verify if the assignment is correct, click the group name here in the left side, then click Highlight, and the Staad will highlight all the slab assigned to this group just like this. To create another group, just click Create. Now let us create another group for T and B. The name is 2F underscore 2E underscore CR. Then let us assign this. Then let us create two groups for one-way slab. One group for balcony and one group for stair. Since the live load in balcony is different from that of stair. So let's create and name it 2F underscore one-way underscore V. This is for balcony. Select floor, then click OK. Next, another group 2F underscore one-way underscore is. Click OK and let's assign. Highlight the slab. Click Associate to selected geometry, then click Associate. Now let's go back to floor load application. Click Reference Load DL, click Add, select floor load, then click Group. Select the first one, which is two-way. Our floor load is 6.35 kN per square meter. Type 6.35, click Add. Select the second one. Select the third one. Select the last one. Don't forget to click one-way distribution if it is a one-way slab. Next, we will apply the uniform load for beams here at the second floor. For external wall, uniform load is 7.75 kN per meter. Highlight reference load DL, then click Add. Click member load, type 7.75. Click Add. Click Close.
Highlight this load.
Select the beams where the load has to be applied. Click Assign to selected beams. Click Assign. Next, line load at balcony is 3.6 kN per meter. Click reference load DL. Click Add. Select member load. Type 3.6 kN per meter for the balcony. Click Add, then Close. Highlight the load. Select the beams in the balcony. These beams, click Assign to selected beams, click Assign, then click Yes. Next, load at bathroom, which is 7.45 kN per meter. Click Reference Load DL, click Add, select Member Load, type 7.45,
Click Add, then click Close.
Reference Load DL, click Add, click Member Load, type 0.34 kN per meter. Click Add, let's assign the load, select this beam, assign to selected beams, click Assign.
Reference load DL,
Click Add, click Member Load, type 0.68 kN per meter. Click Add, let's assign the load, this beam, assign to selected beams, click Assign. Next, load at the partition wall, which is 0.95 kN per meter. Click Reference Load DL, click Add, select Member Load, type 0.95, click Add, then Close. Click Assign to selected nodes, click Assign. Now display the whole structure, and let us go to ground floor. Isolate ground floor. Reference load, dead load DL, click Add, click Member Load, type 9.61 kN per meter, then click Add. Close. Let's assign the load. Select this beam, this beam, this beam, and this beam. Click Assign to selected beams, click Assign, then click Yes. Reference load, did load DL, click Add, click Member Load, type 1.2 kN per meter. This is the load in the partition ground floor. Click Add, Close. Let's assign the load. Select this beam, and this beam. Click Assign to selected beams, then click Assign. Click Yes. Now display the whole structure. We don't have floor load at the ground floor. What we have here is the slab on grid, and its load will be transmitted to the ground. Next, let's add a live load. Click Reference Load LL, click Add, click Floor Load, then click Group, type 1.9, Add, select another two-way slab,
type 2.9 kN per meter,
live load, this is in balcony, Add, type 1.9 kN per meter for the rest of the slab. After that, we'll set up our rigid diaphragm. Go to View,
left view. Let us assign a rigid diaphragm at the second floor, and that is 5.6 meters from the reference point.
using the node cursor. Select nodes at second floor. Go to Specification, click Node here, click Floor Diaphragm. Now this is 1 and this is 5.6 meters. Then click Assign. Next, go back to Loading here and expand the definition. Then let's go down to Seismic Definition. Click Seismic Definition, click Add. In the drop-down menu, look for UBC 1997 and click it.
Replace all the tabulated values 0.4, 1, 8.5, 8.5,
So we'll profile type 4, in A is equal to 1, in B is equal to 1, and 0.0731. Here select reference load, then select reference load DL, bring to the right, click add, and then let's go down further. Click load case details, then click add. Number 1 primary load case is seismic. Type AX for earthquake along X, then click add. Next AJ for earthquake along J direction, click add. Next dead for dead load, type here DL, click add. Next live for live load, type LL, then click add. Next rope live, type RL, click add. Next wind for wind load, type WLX1, click add. Next type WLX2, click add. Next type WLG1, add. Type WLG2, click add. Take note, we don't consider MWFRS in this structure, for we are accurate that wind loads will not prevail in this structure considering the height.
However, we have primary loads WL1 and WL2.
This is the wind load coming from the roof that we calculated in our previous video. Now we are done setting up with our primary loads. Let us go back to first primary load AX, highlight it, then click add. Select seismic loads,
Click X direction,
turn on factor for accidental torsion, then type 0.05. Turn on factor for natural torsion, and it's gonna be 1. Click add, then close. Next, EG, click add, click seismic loads, click J direction, again turn on factor for accidental torsion, and it's gonna be 5%. Multiplying factor, type 1, click add, close. Next, DL, click add, click repeat load, then select reference load, DL, bring it to the right, and this time change +1 to -1. Click add, then close. Next, LL, click add, click repeat load, select reference load, then select reference load LL. Bring it to the right just like this. Change +1 to -1, click add, then close. Next, RL. But our load for this comes from the roofing, so we will open our load in the Excel file. We will start from the dead load. So in the drop down menu, deselect everything, deselect all, then select DL only, and then click OK. Copy the right side portion as shown here. And paste it here. Next, minimize the Staad editor, then go back to Excel file. Next, select LL alone, deselect DL, then click OK. Now, let's do the same procedure. Copy the right portion starting from joint load as shown. Paste it under LL as shown. Again, just minimize the Staad editor, then go back to Excel file. Next, select RL. Click OK. Same procedure. Paste it right below RL just like this. Next, WL1. Same procedure. Paste it right below WX1. Next, WL2. Select WL2, deselect WL1, then click OK. Same procedure. Paste it right below WX2. Next, WLG1. Select WLG1. Paste it right below WLG1. Next, WLG2. Select WLG2. Click OK. Paste it right here below WLG2 and then exit Staad editor. Click yes to save changes.
Now we'll create load combinations.
I have video on how to create auto load combinations. Click load case details, then click add, select auto load combination. And in the drop down menu, select NSAP 2015. Select drift, then we type 100 as starting combination number to easily remember this load combination. Then click generate loads, click add, then close. Again, click load case details, click add, click auto load combinations, select NSAP 2015, then select concrete design, type 200 for the starting combination number. Click generate loads, click close. Again, click load case details, click add, click auto load combinations, select NSAP 2015, then footing design factored. Type 300 for the starting combination number, click generate loads, click close. Again, click load case details, click add, click auto load combinations, select NSAP 2015, then footing design service. Type 400 for the starting combination number, click generate loads, then click close. Again, click load case details, click define load combinations, type DL plus LL, type 500 as the combination number, highlight DL and LL, bring to the right, click add, click close. And we are done with the load combination. So let's go to analysis page here, then click analysis commands. Add perform analysis from this dialog box. Click add, then click close. Click post analysis commands. Then from here, click define commands. Add load list. Our load list starts from 100 to 123, which is the group of equations for drift calculation. Click the single arrow to send the equations to the right. Click add. Click story drift. Type story drift factor equal to 0.0042 if period is less than 0.7 second, or 0.00336 if period is greater than 0.7 second. Go to Utilities, then click Command File. Scroll down to the last line. Double click Finish. Add 2 lines above Finish. Type change. Press Enter. Then type Perform Analysis. Then exit the Staad editor. Click Save to save the changes. Done. I have video about response modification factor where displacement amplification factor is being discussed right there. Click Run Analysis. Click View Output File. Click Done. Then click Messages. Now we have one warning here. So to remove the warning, we will just add 2 lines under seismic load case. To do this, go to Utilities, then click Command File, then look for the word Define New VC. Press Enter, then type Change. Press Enter. Next, exit the editor and save changes done.